This lesson is about how to complete algebraic segment proofs. Just like a regular proof, we want to make sure that we copy the given into the problem. So this says given xz equals 30, proof t is 11. You always want to make sure that you copy and paste the given exactly how you see it. You're not going to change anything. This is just going to read xz equals 30. My reason is given. Once you get to this step, you need to write a general equation. I have no vocabulary here, so I have to either use segment addition postulate or angle addition postulate. Well, this is clearly a segment, so I want to make sure to use segment addition postulate. My general equation is xy plus yz equals xz. And my reason is segment addition postulate. The abbreviation that we like to use in class is SAP, S-A-P. Now that we have our general equation written, we're going to go ahead and substitute numbers in. xy is 7, yz is 2t plus 1, and xz is 30, and we got that from the given. This is called substitution, property of equality. As far as your proofs go, everybody's proof has to start out like this. Once you get to here, you can solve math however you'd like, meaning some of you want to add or subtract the 1 to the other side. Some of you prefer to combine like terms. I'm going to go ahead and combine the 7 and the 1. So 7 plus 1 is 8. Let me go ahead and fix that. 7 plus 1 is 8 plus 2t equals 30. That's called combine like terms. Now I'm going to go ahead and do my algebra, and like we talked about in algebraic proofs, you don't want to show your side work. So I'm going to end up erasing my side work at the end. I'm going to bring down the 2t, and 30 minus 8 is 22. And we used subtraction, property of equality, because we subtracted 8 on both sides. The final step is to isolate t, so I'm going to go ahead and divide both sides by 2. 2 divided by 2 is 1, so we're left with just t. 22 divided by 2 is 11. And we use division, property of equality. Notice how our proofs are all lining up. Every statement has a reason, and it's balanced. Balancing is the key to writing a nice, neat proof. Again, we can check our final answer because it should be shown that t equals 11, and t, in fact, does equal 11. So at least you know you did the problem right. Let's go ahead and do one more, and this one involves midpoint. Now, midpoint, remember, is a little bit trickier because you have to use that definition of congruency. So it says, given m is the midpoint of Ln, prove x equals 2. Again, math is not going to change. The given is still written first, even if it's a bunch of words. Doesn't matter. The given is the given. You have to write it the way you see it. That's always step 1. M is the midpoint of Ln. You know what? It's okay. You can go to the other line of proof. It's not that big a deal. Just make sure when you write the word given that you write it nice and big so it matches and balances. From here, reading my problem, I don't see just something equals 30 like I did in the last one. However, I do see that the vocabulary word is midpoint. When I see vocabulary, I should define it. Definition of midpoint. What that means is segment LM is congruent to segment MN. Got my white out again. It's congruent to MN. We can't just go ahead and substitute. We need to make sure that we set it equals. So segment LM equals MN. That is called the definition of congruency because you're going from congruent to equal. And that's the step that you're going to forget the most. The definition of midpoint is that they're congruent first. The definition of congruency changes it to equal. Now that I'm in terms of equality, I can substitute my values into my equation. So LM is 3x and MN is 2x plus 2. Substitution, POE. Now, everybody's proof has to start like this. There's no way around it. There's no shortcuts. It's got to start like that. Once you get to this point, now you can solve algebra the way you want to. So most of us would like to get the x together, so I'm going to move the 2x through subtraction. 3x minus 2x is x equals 2. Subtraction, POE. We know that we finished our problem because it said prove x equals 2, and we showed x equaled 2. And again, I'm going to go ahead and go back and just erase all that side work. Remember, your proof is supposed to be like a final draft of a paper, so you want to make sure that there's no work or solving your little properties of equalities. You just want to make sure that every line is perfect.